In this training module, we will be discussing ventilating confined spaces and hazardous locations. Please see Ventilating Confined Spaces Part 1 module prior to reviewing this module. It contains the regulations and fundamentals of confined space ventilation. The key topics to remember from the non-hazardous training module are: what is a confined space? How to evaluate a confined space? Positive ventilation is the most common type of ventilation. Types of ventilation equipment. Centrifugal blowers have a squirrel cage and axial fans have traditional fan blades. The saddle vent increases productivity. If you are not familiar with these topics, please review the non-hazardous training module prior to continuing with this module on hazardous location ventilation. Read and follow the recommended procedures found in the American National Standards Institute, ANSI, and the American Petroleum Institute, API, 2015 and 2016 prior to entering a hazardous confined space. Static electricity is a source of ignition for fire and explosions when exposed to combustible gases and fumes. Choose ventilation duct with fabric made of conductive material. This type of duct will reduce the potential buildup of static electricity on both the interior and exterior surfaces of the duct, resulting from the movement of air and small dust particles during ventilation. Air System designed conductive ventilation duct and accessories to safely remove potential electrical charges from the ventilation system. Air Systems adds a grounding wire to the conductive ventilation duct's interior wire helix. The grounding wire attaches to the grounding lug in the conductive ventilation accessories and blowers. This is an extra safety step to ensure any static charges can be removed. This provides the safest possible confined space ventilation available. Now that we understand conductivity in confined space ventilation, let's discuss the most commonly asked question: what type of blower should you use? The answer will depend upon the confined space. Let me explain why. There are so many confined space situations, locations, sizes, and other variables that there is no one-size-fits-all solution. The first thing to consider is the blower certified for its intended use. For example, is it going to be used outdoors? If so, is it approved for outdoor use? Surprisingly, not all blowers are. Here is a visual that helps break down the various types of hazardous location blowers and fans. We do have a video online if you would like additional information on selecting a blower. Additionally, you should verify that all components in the ventilation system are certified for hazardous locations. All Air Systems International blowers have nationally recognized testing laboratory certifications and approvals for ventilation. This is critical to worker safety and required by OSHA. The explosion-proof electric centrifugal blower is approved for use in the National Electrical Codes, NECs, Class 1, Division 1, Groups C and D, Class 2, Division 1, Groups E, F, and G. It is important to ensure that all electrical equipment use and installation comply with the NEC codes. Additional consideration when selecting a blower is to determine if there are any workplace lifting restrictions. An ergonomic roll cage not only provides multiple lifting points for two-person lifting, it also protects the blower components from damage during transport. The explosion-proof electric axial fan is rugged and lightweight. The conductive polyethylene housing has a static grounding lug, a sealed on-off switch, and an explosion-proof electric motor. The explosion-proof canister fan is a two-part system that includes a duct canister and axial fan. The duct canister quickly and easily attaches and detaches from the axial fan, making for faster setup and teardown, increasing worker productivity. It also extends the product life of the ducting during transport and storage, and there's no searching for the correct duct when it's time to ventilate. Once again, versatility is an important point in ventilation selection. The inline axial can be used as a standalone fan or can be used inline to extend ducting length for longer ducting runs. The large handle also makes transportation easy. There are over 300 plug options available. Find out what type of plug is needed before ordering. When the plug is ordered with a blower, installation is free. By default, the electric hazardous location fans and blowers will ship without a plug attached unless one is ordered. The end user can wire a plug onto the blower or fan assembly themselves as long as they follow NEC requirements. The plugs will attach to the 25 feet of Mine Safety Health Association MSHA rated cable. This is an explosion-proof electrical cable rated for mining operations, which is extremely safe. There are two ways to address limiting static electricity in hazardous locations. Usually, the decision will come down to how will you be powering the ventilation system. If you have access to an electrical power source, then the explosion-proof blower is ideal. However, if you are running off of compressors, then the pneumatic blower would be your choice. The Air Systems pneumatic centrifugal blower is one of the most versatile blowers with fully adjustable air volumes from 15 to 3,000 CFM. Other types of pneumatic blowers include the Venturi blower and circular jet fans. Venturi blowers are often referred to as air horns or reductors. Here are some examples on how they can be used. Blowers, fans, and ducting are not the only things you should research when selecting your confined space ventilation equipment. Choosing the appropriate confined space ventilation accessories can save time and money while adding to worker safety. The best example of this is the conductive saddle vent. It is designed with conductive polyethylene. The saddle vent is amazing in its simplicity. Use the conductive saddle vent with any hazardous location blower or fan to increase worker productivity and decrease risk of static electricity buildup or discharge. The conductive saddle vent allows for continuous ventilation without ducting removal by maintaining continuous ventilation in a confined space area until the job is complete. Without the conductive saddle vent, the ducting will have to be removed so the worker can enter and exit the confined space. This costs more money and could make the environment dangerous due to lack of ventilation. Designed and patented by Air Systems for advanced worker safety during hazardous confined space ventilation. Air Systems offers specialty and custom blower options. Please contact us if you have unique applications and situations. We have covered quite a bit of information. Reviewing these questions will help guide you regarding your ventilation needs for confined space entry. Let's take a look at what those questions are. Is there potential for an explosive atmosphere? Do you have a blower designed and certified for the job needed to be done? Will you have access to electric or compressed air? Do you have the right conductive ducting and accessories for the job? What type of confined space will be entered? Is it a sewer, a tank, a silo? What is the quality of the ambient air to be used to ventilate? What are the dimensions of the confined space and how many access openings are there in the confined space? Should you have further questions or need assistance, please contact Air Systems International, the leaders in innovative safety products for over 30 years. We would like to thank you for taking the time for this training module.